All right, recording is on, and I want to thank God again for a beautiful day. Let us know that we have two more lectures to go. Today is going to be a lot of activities today. We're going to cover two topics today: correlation and t-test. And by next week, we're going to go into ANOVA, and the last week we'll go into regression. So many things have to be done. We have to cover this area. After today's lecture, I'm going to give you independent t-test and other examples of t-tests for you to do and answer the questions involved. So that is the only way we can, go to cover the activities that we have. If you look at the previous outline, I said today we'll go into t-test, but I just remember that I've not taught you correlation. And correlation is one of the simple SPSS, statistical analysis, that we do to compare certain concepts that we should have. All right, before we go ahead, may I ask any of us, no matter how small the knowledge, there's no small knowledge, by the way, no matter how limited your knowledge is on the concept of correlation, when we say Pearson has is just a version. It's a bivariate Pearson. It's a version of correlation that we are using. But by the way, correlation is generic to every other concept of correlation of the versions of correlation. Let me ask us, what do we mean by correlation, by the way? Please, anybody, you can unmute and speak. Just tell us what you know. There is no, like I said, there is no limited knowledge. There is no small knowledge. There is no inadequate knowledge. We are just building. We are building on what we have. What is correlation? How do we use it? Anybody?
So I think it's a major relationship to see if there is a relationship between different variables that the researcher is interested in to measure.
Good. Good. That is just it. It's anywhere you are talking about hypotheses that mention relationship, association, relationship. Do you hear that word? Someone asks, how do we know the SPSS, the statistical analysis we use? There are certain terms that once they are mentioned, you will know where to go to. By next week, or I think I should give you an example by next week, and the last week I will give you another, scenario from. I will just pick one of the projects I analyze here and show us and ask us questions, and we'll solve it together. So anywhere you see question requesting for association, relationship, you should know that what you are referring to, looking for there, is what? Is between correlation and what? And regression. Okay? But for today, it is basically what? Relationship. Relationship. How does one product affect the other? And we'll look at that briefly. I dropped a number of contents here. Don't be scared. A number of people say, I just did it, I'm not sure if I got it. Yes, don't worry. I gave you the whole notes here. It doesn't mean that you have to understand it by principle. When I say understanding, it is not related to the SPSS, but it is a mathematical calculation, the theory behind the SPSS. So when you get to some mathematical area that you are not clear with, by the way, I'm going to jump it because you may not necessarily need it. But for those of us who are mathematically inclined, you will understand it. It's a manual way of doing the calculation before we get to the computer concept. So look at the word here, relationship. I'm going to between pairs of. Look at it. This is very, very important, gentlemen and ladies. The relationship has to be what? It's a linear what? It's a direction of what? Linear relationship. When we have relationship, not only relationship is going to give us what? The direction, the strength of that relationship will be included. And that is why I have to underline this and put it in red. The strength and direction of linear relationship between pairs of what? Continuous variable. Okay? Can someone give us an example of continuous variable? Anybody, please. That's where we started from. That was our introduction. We started from different variable, interval,
Age, sir.
Okay, thank you so much.
Age.
Thank you so much, because age has to do with numeric, and it has no end. When we say continuous, you can have 1, 1.5, you can have age, you can have height, and sometimes they say continuous variable or what? Or ratio or interval. Sometimes they also have it that way. So that is one of the things that we'll look at in this in correlation. So the measure is also known as Pearson correlation, and some other point you see it as what? Pearson product movement correlation. Those of us who have done the calculation before will see it in that way. So it's a correlation that looks into what? Relationship among what? Pairs of variable, and this variable compulsorily has to be what? Continuous variable. Okay, let's give a practical example. How does the rain affect the use of umbrella? Raining season, how does it affect the use of umbrella? No, if it rains, does the purchase of umbrella, the investment you make on umbrella, does it go, your household, purchase on umbrella, does it go up? When do you buy?
Yes, sir.
Yeah, thank you. Also, you look at situations whereby right now in Nigeria it's quite hot. I don't know how many of us will want to drink water, warm water right now in Nigeria, except that you want to, medically it's good for you. But under normal situation, anytime it's getting to 1 p.m. right now in Nigeria and you are not under a very good temperature, you'll be scouting, looking out for what? For a cold drink of water. That is the temperature. Now, can we now say that the sales of cold water has a relationship with the weather? Is that possible? So that when the weather goes up, the use of what?
Yes,
Cold water also goes what? Simultaneously goes up. That is it. And we say sometimes we can have a strong relationship. When we say we have a strong relationship, when it is very obvious. For example, the two examples I've mentioned now are what? Very, very obvious. The use of cold water when the weather is hot. Now let's look at another relationship where we are not likely to have a strong relationship. The use of cold water when it is what? During the rainy season. Can we assume that we'll have a strong relationship in that relationship?
No, sir.
No. We may have a relationship because very few people will still have to want to go for cold water, but the relationship is not going to be what? Strong. So that is the level or the measure of our relationship. So our relationship can be strong, can be weak, can be positive, and can be what? Negative. When we say we are having a negative relationship, it means that the relationship is falling down. It's going down. It's not rising. It's falling down. It's falling down instead of rising up, going up. When we have a positive 1, 2, 3, 4, 1, 2, 3, 4 in our chart, if you draw a chart, it will be going higher. But when you have a negative, it's going to go down. So let's take note of this one in yellow. I put in yellow color here. It says bivariate Pearson correlation cannot address. No, please take note. Even when you see, sometimes when you draw hypothesis, you discover that the hypothesis, if it disobeys this rule, then you have to reconstruct it. Correlation cannot address non-linear relationship or relationship among categorical variable. Last week our chi-square and all the measures of mean that we did was on what? Categorical variable. But we are saying now that we are moving to what? A non-categorical variable where we have what? We call it linear relationship. It cannot measure what? Categorical variable. Take note, it cannot measure categorical variable. Look further to what is also written here. If you wish to understand the relationship that involve categorical variable or non-linear relationship, you will need to choose among other what? Measures of association. I told us that, this is strictly on what? Relationship. There is another one on what? Association. Remember, if you remember, the chi-square we used last week was also what? Was a measure of association. Okay? So take note of what each of these can do. Let's just move on and understand more of this concept. Bivariate Pearson correlation only reveal association. Remember, association only. Okay? This is no. Sometimes you look at relationship association. Don't get confused. It's an association between variable, and it must have a relationship. Relationship between one affecting the other, and they are having association. So the use of association and relationship are interwoven, and they are used interchangeably. But one very particular point is clear here, that you cannot use correlation for what? Non-linear variable. You cannot use. You can only use it for what? For a continuous variable, right? Variables that are continuous. Take note of that. Okay. So the bivariate Pearson correlation does not provide any inference about causation, no matter how large the correlation coefficient is. It's not going to give you. Okay. Now let's look at other things that we must consider when we are talking about using what using correlation. There are some other things that we must consider very briefly. If you study this here and you don't understand, please pick books and read more on them. One, two, Pearson correlation, handles two or more continuous variable. That is very, very true. An example is what? Interval or what? Or ratio level. Interval or ratio level. Take note of that. I just underlined that here. Just please permit me. I need to put off my, those of us who are seriously, I need to put off my web, my web WhatsApp, so that the noise that we hear behind will stop. Let's check and make sure that I'm still online here, in line with the recording. All right, thank you. So let's look further on this example we have here. So that's one of the first rule: two or more continuous variable. An example: interval or what? Ratio. Cases must have non-missing value. Do you hear this? We must not have a missing value. Take note of this, please. Very, very important. It is you must not have a missing value. Thank God, those of us who were here last week, we had reasons to learn how to remove what? Missing value. And the video is also there. Okay, at the end of today too, I'm going to share the video towards the end of today, probably by 6 p.m. It should be ready. We'll share the video, and also include other links. We've had 3 videos online now. This is going to be the 4th one. I will share the link. It's on YouTube. You can watch until we are tired of watching, until we learn and begin to build our own. Okay? Because the essence of this is that you should know more than your teachers, and the Bible supports that. Now, the number 3 points here say linear relationship between the variable must exist. The independent cases, independent of what? Of observation. There is no relationship between the variable of what? Between the value of variable between cases. There must not be relationship before you find the relationship. There is no relationship between the values of variable between what? Cases. The values for all cases across cases are for all values. The values of all variable across cases are what? They are not related. That's what we mean by there is no relationship. For any case, the value of any variable cannot influence the value of what? Another variable for other cases. Now, if you want to look at, we talk about weather and water. If you want to look at groups of, non-linear variable, then you have to go to what? A test of what? Independent variable, t-square, and other, which we will go to shortly. Then the next one is bivariate normality. You may have to go and read more on normality. You may not understand with the limited information I'm giving here. But normality in essence is, say each pair of variable is bivariately normally distributed. When we have a normal distribution curve, those of us who are mathematically inclined, you have a normal distribution curve. It starts from the beginning, from the left hand side, from one to what? To 1. Or from 1 to what? To -1. It crosses is almost what we call a diameter of a circle. That is when we have a normal curve. But any other thing beside that is going to give you abnormal what? Abnormal variable, So the next one is that your variable have to be randomly selected. Random sample of data must be what? Taken from the population. What do you mean by that? Every member of your population must have equal chance of appearing. These are one of the conditions that you must follow. When using what? When using correlation. And the last but not the least is that you must not have an outlier. We have explained what we mean by outliers before now, and I hope you still remember. Outliers means that your defined range of variable or value, nobody must default it. If there are, you must learn how to remove outlier. By the way, hopefully by next week, we'll see how we can handle removal of outliers, so that will help us in our analysis. When we are cleaning up our data, we'll be able to include that. Our next concept is the use of hypothesis. For those of us who have not known hypothesis for now, we have two levels of hypothesis. We have the null hypothesis. This is the null hypothesis with the symbol here on the screen in red. And we have the alternative hypothesis with H1. Null has to do with H0, and alternative hypothesis has to do with H1. Yeah, please, can you please mute your Yes.
Just the contribution when it's convenient.
Thank you so much. I never knew you on board. We're glad to have you. Thank you so much. All right.
When it's of convenience, yes. I have a contribution.
Thank you so much. I would gladly have that at the end of this hypothesis. Thank you so much. Now, let's look at this hypothesis here. These two hypotheses here. We have the null hypothesis, and we also have the alternative hypothesis. When you say you have a null hypothesis, it means nothing, it is not going to happen. Null has to do with 0. It is not going to happen. An alternative hypothesis means it is going to happen. Okay, that is the meaning. That is the literal meaning. And let's look at the P here actually has to do with P, population. And very soon we'll go to where we have U, meaning mean. So here I said we have the null hypothesis here. Say the population correlation coefficient of 0. There is no association. No, meaning it cannot happen. No. This is no. And when we have alternative, means yes, it can occur. And that is why we say that the population correlation coefficient is not 0, meaning this is 0, not 0. That's another way. This is yes, this is no, this is yes. So it can be written, it can be used, interchangeably. Now, the next questions that you may be wondering that now, which one do you use when you are populating your hypothesis? Like, we'll see examples very soon. It depends on the school of thought and the institutions where you are working with. Some believe that we should adopt null hypothesis, which is my also area of school of thought. And some also believe that you can also adopt what? Alternative hypothesis. And some also believe that you can use the two. Now, what is hypothesis, by the way? Hypothesis is a statement of assumption. You can predict what your answers will be before the answer comes. The prediction is not saying that is the final answer. The prediction will be vindicated or finalized when you finally use your statistical analysis to justify the answer. So at the end of the day, when you have the answer, you can now say, yes, the hypothesis set was what? Is correct and is therefore adopted. And sometimes when the hypothesis, that is mean the assumption you made is incorrect, you reject the assumption, which means your hypothesis can now be what? Be rejected. And so doing, the null and alternative hypothesis fall under the test of two-tailed significance, which that's what we call it, and we'll see further examples on that as we go. While on the other hand, we have one-tailed significant test. And let's look at how we formulate this one-tail. On the one-tail here, we don't have, this is no. No, look at this. It means no. This is equal to, this is not what? Not equal to. And that's why we say not 0. Now, instead of saying not 0 here, we have greater than, which is, look at null here. the correlation coefficient is 0. It's still the same wordings and the same expression. While here, there's a slight difference between this and this for one tail. It said the population correlation coefficient is greater than what? 0. Okay, here we say it is not 0. Here we say it is greater than 0. In other words, it is still not the same as both of these. This is alternative. This is 0, but this is greater than 0, which means that your answer is not going to be 0. And this is just an assumption. Let's put it in a practical term here. It is possible that the purchase of cold water, during the dry season is what? There is what? There is no association between cold water and the weather. This is what it's saying. Coefficient is 0. There is no what? No association. Here it says what? There is what? There is coefficient is not 0. Mean non-zero coefficient could exist. Mean there is what? There is association. So the same thing goes with this. Here it's not saying categorically that there is none, but when you have your coefficient to be greater than 0, it means definitely there is an association. Sorry for those of us who are non-numeric compliant. When you have any value that is not 0, is greater than 0, it means that you have 1, 2, 3. It means an association exists. And as we mentioned earlier, this association, we'll see, it varies. We can have a strong association, which is 1, 2, 3. We can have a weak association, which may be 0, -1, -2, and etc. These are the levels of the strength of the association we may have. And when we say strength of association, I mentioned earlier that we can have rainy season, cold, and some people still indicated that they want to take cold water. Now you test, is there a relationship between that weather and the cold water? He said no. However, there could be a slight one that's very, very insignificant that you cannot measure. Thank you. All right, Prof, you have the floor, ma'am.
Thank you very much. Because I'm in the audience,
Yes.
I believe there are some who, like you said, may not be in the mathematical discipline,
Yes.
so that sometimes they might get confused along the way, even though it's understandable what we have explained now. But for emphasis, I just want to underscore the point that, yes, for correlation, we are looking at association, because relationship also, like Dr. Maitomi said, but sometimes, you have causal relationship as well. But correlation does not deal with causal relationship at all. It's association and then linear relationship. And then when you're looking at variables that are categorical, then you can look at chi-square as your means of correlation. But when it is continuous, like age, like weight, like height, then you can look at Pearson products or Pearson correlation. So that's just something I wanted to add for those who may not have had the background before.
Thank you so much, Ma. And I will appreciate if you have more as we move in the line of discussion. It's welcome. Just because I can't see the back, I'm actually recording, and I don't want to flip.
That's
so
why I had to speak. I was
will,
raising my hand first.
No, I can't see. I'm not. We are recording, and the software will not allow me. If I flip back, I will lose touch of the screen. Thank you so much. And the same goes to everybody, please. We are from different disciplines here. I have lawyers here. I have nurses. I have computer science. I have public health expert. I'm not. Remember, we are all students. We stop learning when we die. Even when we retire, we still keep learning, even from our children, grandchildren. So I don't know it all. That was declared at the beginning of this training, right? So let's learn from one another. You have read something, bring it on board, and we'll see how we can learn further and read further. Thank you. So let's move to the next stage. Let's see. Now, this is the strength of the association or relationship we've discussed. Let me stick to the relationship so that we don't get confused. This is the strength of the relationship. Now, when we have -1, this is when -1 has to do with what? Negative linear relationship. It is negative. And I've told us reasons why we can have a negative linear relationship. And when we have zero relationship, it means there is no relationship at all. And I'm going to ask us a few questions on that in the next minute so that we can drive this home. And when we have plus one, we have perfectly positive linear relationship. When do we have this? We will see as we also move along the discussion. Now, let's look further on the strength of relationship that can always guide us. These are just like a baseline that we should put beside our working bench when we are working, so that when we come across this, we'll be able to speak boldly. What's your relationship? What is the kind of relationship? Say, oh, this is weak. This is not weak. This is strong, and all that. Now, the next one here is look at this. Point one is just less than R. R is relationship. Less than what? 3. It means that small, weak correlation. Small, weak correlation. This is still weak. It is small. So you can call it small correlation. You can also call it what? A weak correlation. Now, when do we have high correlation? The moment you have what? Greater than what? 3. But what? You have less than what? 5. So we can call it medium or what? Moderate correlation. But anytime you have more than 5, it is large or strong correlation. All right. Please, you have the floor.
Yeah, but again, so
Yes.
that they will not be confused.
Please go ahead.
Point 3, point 5, that they are not looking at it as positive 3 or 5.
Yes.
That it's 0.3 or 0.5.
Thank you.
So if there is no correlation at all, that is, there is no association between the variables. Like when you are looking at the size of the head and intelligence, there's no correlation at all. It doesn't mean that the bigger your head, the more intelligent you are. But you can also have the negative, which is inverse. That as one is increasing, the other one is going down. It's still linear, but one is increasing, the other one is going down. You also have curvilinear. You have the positive, which means as one is increasing, the other one is also increasing. They usually give this example. Sorry, Dr. Maitomi, I know it's an example we use in class too.
Yes, go ahead.
That, for example, intelligence, is it intelligence I want to use now? And age. As you grow older, you increase in comprehension to some extent. But then your mental development goes up, but then it plateaus at a time, and then as you are growing older, what happens? It drops. So that's like a kind of curve. Goes up, plateaus, and then comes down. It's called linear. But when it's linear and positive, it means that one variable is increasing, the other variable is also increasing, and that gives you a straight line.
Yeah.
But the inverse is when one is increasing, the other one is going down. It's also linear, but in that case, is negative.
Thank you.
So it could be any of those 3.
Thank you, Prof. Thank you. Class, I've just corrected what we have on the screen, 0.1, 0.5, so that we don't get confused. And that's what we have, in the other line here. And what Prof just gave us now is what we have here, right? If you look at, this is a scatter diagram. And if you have to talk about this diagram now, this is negative 0.9, 0.9. And how do we have positive and how do we have negative? Okay, maybe you permit me to draw something on the screen slightly, and I hope, I'm sure we should be able to see this. Okay. Okay, can we see what I have on the screen, everybody? The lines that
Yes,
just
sir.
drew. Okay.
Yes, sir.
Thank you.
Yes, sir.
Now,
Yes, sir.
all right. I just want to show us the positive side and the negative side. Now, this is where 0 starts from. And from this side of my 0, to this side is what we consider positive side. And from this, that is from the horizontal to the right is positive. And from the same horizontal starting level, 0, to this other, side, left-hand side, is what we call the negative side. Okay? That is what we call the negative side. So if you look at this diagram now, you discover that this is our starting point. Now our diagram is it moves towards where? We have it's tilted towards where? Look at it. We have 0, 1, 2, and it moves up and it's going higher, going up towards what? Towards the left hand side. And that is how we measure what? 0.90. Minus, thank you. You can see 0 here. After, when you leave the 0 point, you count what? Towards the left. Depending on your metrics of measurement, it could be 1 to 1, which means 1, 2, 3. But looking at exactly, that's 1 to 1 here. And that's why we have -1, -2, -3. And the same measurement you use here is the same measurement you must use at this other scale of the positive side, so that your charts can be the same. So when you move towards this side, you also have 1. Usually in arithmetic, when it's positive, except in calculation, we don't usually put plus or plus into it, because it's 1 and plus is the same thing. But when we do some advanced calculation, we may do that. But in statistics here, we don't put plus, except we have negative, then we indicate negative side. So the left hand side is the minus side, and the right hand side is the positive side. And I'm just trying to defend that with the diagram here. Then the question you may ask is that, then what is the vertical side, that runs from the 0 up? We also have 2 of it. We have the positive here, and we also have the negative down, not up now. We have it down this level. We have the negative down this level. Sorry, I may have to. Okay, good. We have the negative this level. You may not see the limit or the end of that arrow, but this is the negative side. So we also have 1, 2, 3, 4, 5 positive here, and we have -1, -2. So as a matter of fact, you discover that the negative side here, the negative side owns this level. This is the negative. And we have what? We have the positive side to be where? To be here. And we have the positive side to be here. And we also have what? The negative side to own this side. Anytime you are leaving this 2 to the left hand side, you are going towards the negative side. I hope that makes the lesson better, in terms of a figure from those of us who don't have the previous knowledge of arithmetic. So if you look at this now, what can you say of this? It's scattered. Let me ask you a question, class. Can we think of any relationship here where we have R equals to 0.00?
No, sir.
You can make no. Yeah. There is no correlation, no relation. Everything is just scattered. We have one that is shooting outside 2. We also have one that is going -2. Everywhere. There is none everywhere. Just like Prof said earlier, what's the correlation between the size of head and intelligence? Is there anything? Can we say there's a relationship between the size of head? Your head is so big, and we would assume that you are so intelligent. Is it possible sometimes? No. Okay, now let's move to the third one here. Okay, now look at this. We move from the negative. We move to the normal distribution, the center. Okay, and we shot outside the center to the positive here. So at the end of the day, you discover that this is what? This is linear. This is linear. This is linear because it's a straight line what? Correlation relationship. However, if you want to tell us the size of this now, this is -2 to what? To 2. So where do we place that? So you can say, -2. -2 will tell us what? Perfectly what? Negative what? Linear relationship, because it started from negative going towards what? Towards positive. Or you can say that it's starting from positive shooting towards what? Down. It actually rises at a point, And after a while, it came down to what? To a negative concept. So we can have some scenario to support that idea or that statistical assumption, which we'll see in our example very soon. If you have questions, contributions, please don't hesitate to just stop me and say I want to contribute, just like Prof has done earlier. So let's go to an example here. Now, sometimes before we run our SPSS, we usually want to do what we call find the scatter diagram. We see how we can do that too. We see how we can do that. But before then, let's run to some of the tools we use under correlation. When you pick your SPSS, we've been working on analyze. You click on analyze, and you have correlate. You have bivariate. That's the choice of the correlation we have now with the SPSS. And from here, you have your variables displayed by the left-hand side. And you can then have your label as we have on the screen. That's how the tool is labeled. So I want us to have ideas. And before this morning, earlier this morning, I posted all that we need to use. So by now, you should be working with me too. All that I'm doing, I have given you already. In fact, the data I'm going to run now, I have also forwarded it to you so that you can walk along line with the teacher, so that you, apart from demonstrating, you can also see the evidence at your end. So if you have opened this, like we will open very soon, the first A here is where you move the variable you want to use. You move it here. And we have B. When you leave A, we have, after moving the variable, we have area here, we have correlation coefficient, and we have the B. Right now we have some coefficients we are working with, which we call the version. Sometimes we work on Pearson. Some other times you can be asked to look for what? The Kendall top. And some other time we have what? Spearman's what? Correlation coefficient too, depending on the product in question you want to use. But most times the answers are highly what? Related. Highly related. Now when you leave B, you go to C. You, by default, C, the test of significance is always two-tailed. And before now, I've explained to us the meaning or the difference between having a two-tail, where we can have significant, no significant, and the one-tail is just that greater than, instead of saying no significance. But by default, we would have two-tail. When you leave that, if you want to have one-tail, just click on the button, that says one-tail, and it will be, your answers will come out in one-tail method. And when you leave C, you come to D, where we say flag significant correlation. At this point, it's going to indicate your answer will come out if it's significant and if it is not significant. We will learn more of the concept of significant very soon. And the last one here, which is E, is options. There are other things that you can still make use of that are not displayed visibly outside here. And they are what? Within this concept of E is what we have what? We have mean, standard deviation, cross product deviation, and covariance that we can always use. And we have them here. Means, this is the E button now. Means and standard deviation, cross product deviation, and covariance. And we can also talk about exclude cases what? Pairwise, which we call missing values. Last class, we saw how we can eliminate missing values. So your missing value can be done using what? By excluding what? Cases pairwise, or you use what? Or you use likewise. I think I have an explanation to that somewhere for you to, okay? Yeah, I have it here. Exclude cases pairwise or likewise. Note that the pairwise likewise setting does not affect your computations if you are only entering two variables, but can make a very large difference if you are entering three or more variables into correlation procedures. For this morning, we are going to see one variable. So for one variable, it's not going to have effect, except we have more than what? More than two. Then we can talk about either we are excluding pairwise or what? Listwise. You can read more on that. The essence of this class is a little theory, more practical, so that we can understand. All right, let's look at this statement, call it statement of the problem now. Let's look at this problem and see how we can solve it. Then we'll give room for questions and move on to another thing. Perhaps you would like to test whether there is a statistical significant. Look at that. It's saying this is the concept. One, statistically significant linear relationship. We are looking for a linear relationship, which means a relationship that is what? A straight line, just like we had earlier. This is a linear, because linear relationship, look at 0.9. Just if you have to approximate, for those of us who are a little bit in the mathematical area, you know that this is almost what? This is almost 1, which means a linear relationship. So this is what we want to find out. If our relationship is going to be like this one, the third one here, the third diagram here. So let's look at that question further to understand it. Perhaps you would like to test whether there is statistically significant linear relationship between two continuous variables, width and height. Which means the more you are getting bigger, the same way you are getting what? Taller. Is there a relationship like that? By extension, infer whether the association is significant in the population. You can use a bivariate Pearson correlation. You can see now, this is where the kind of correlation you will use will be given to you. If not, they can tell you to use what? Product moment what? Correlation, like we have here. We have a Spearman's correlation. We have what? We have Kenda. Here, it says use what? Pearson correlation. So sometimes, if it's under examination, you may be given. But it's on a practical level that you will determine what to use. Please, this does not affect your result in any way. Okay? The only way you have to consider if results will be affected is when you talk about your bivariate correlation option, when you are using more than two variables. But for what choice of the product to use here does not affect the final result. So take note of that. So here we are asked to use a bivariate Pearson correlation to test whether there is a statistically significant linear relationship between height and width. Okay? And to determine the strength and direction of association. Remember, the strength is it weak or what? Or not weak? The direction, is it negative or what? Or positive? I think we established that earlier. Now, before we do that, sometimes it is possible for us to test our hypothesis with what? With a scatter plot diagram to see if it's going to be statistically significant or not. And that is why we normally do that. Here it said go under your what? Analyze, use what? Descriptive. And under this we see graph and others. So let's see how we can create this and come and compare our answer to what we have here. That is just the question. The solution here is for you. When you go home, you can see the solution here. Let's go and carry out our analysis and come back here and compare our answer to what we would have here. I've given you a data behind on width and height. On width and height. You can work with it and go along with us as we solve this problem together. So we are going to look at this But before then, we'll test and see if this is going to be linear or not. And if you look at the diagram here, I think it's actually is linear, but not perfectly linear, because a lot of dots are outside this level that are not correlated. They are scattered, but we can still say we have a what? We have a linear relationship, though it's not perfect, meaning that
Can
height.
I say something when you're done?
Please go ahead, man. I'm almost switching out to the SPSS side. All right.
Okay. Again, because of those that are not mathematically inclined, what we're trying to say here is that if you have the continuous variable like weight and height, that means in a population, you have a number of people, you have taken the data on their weight, you have taken the data on their height. And like we have this graph now, the horizontal is the x-axis. And on this particular one, the horizontal axis is where you have the height. And then the other one is on the weight. So which means you have values, you have data on height, you have data on weight for each member of the population. Now, it means that when you are taking what's the weight? Let's look at 150 now. 150. When you want to put your dot, you trace it to the height. What is the height? Maybe the height is around 60. So when we trace that 150, and then you look at the height, you have your dot, 150, but the height is 60. So inside the graph, yes, up, towards 150. So around that place is where you have that's where you have your dot for that individual. And then maybe 200 again. When you look at the weight, it's 200. If you bring it inward, that means the height will be around maybe 70 or thereabout. Around 70 or thereabout. Up to the line. Exactly. So you see that as the weight is increasing, the height is also increasing. And that's why you have a scattered diagram like this, where the dots are scattered, but it's tending towards a positive linear, and you can now have a straight line. But if it is negative, if it is decreasing, maybe the weight or the height, the weight is decreasing as the height is increasing, you see that the taller the person is, then the lower the weight will be, the less the weight. And that will be a negative, though linear, but it's going to be a straight line because it's inverse, but it's going to be negative. So, but the example we have now is the example of a positive, which may not be very strong, but it's still a positive. You can see the line. When you look at the scatter diagram, you can still draw a line that goes up that way. Exactly as Dr. Maintam is already showing it. You see, 250 is also around 75. As you go on, the weight is increasing, the height is also increasing. That's what this scatter diagram is showing us. And it shows that there's a positive linear relationship. So that when you now do your correlation, your R will be positive. It will be maybe above around 0.5 or slightly above 0.5. But if it is now negative, it means the dots will not be on that side. It will be on the other side, and the straight line will not be this way. It will rather be inverse. It will move from like 350 down to 85, because as the weight is increasing, the height is reducing. I don't know if it's clear, but just trying to make it simpler for those.
Thank you so much, man. Thank you so much. With this, Prof has really taken it down. I thought I shouldn't bother you with this, but I think it's very important, as Prof mentioned it. There are a number of things I have to skip so that you don't get confused. But sometimes we need to know the theory so that the practical will be very, very easy for us. And that's what Prof has just done. So how do we do this manually? That's what Prof has just given us. This is the x-axis, the where we have the height here. We have the x-axis. Where we have the weight is where we have the y-axis. Okay, that's is constant. It's not something that we can interchange. Okay, so sometimes too the weight can go there and the height can go to the y, and they will tell you if that has to change. But this is the normal way of drawing our scatter diagram. So I want to believe. Let me just save this. I can still send this later. In addition to the one sent earlier. So let's see how we can generate this on a SPSS. When we generate this, then we go and analyze it and write our report. Remember, the way we analyze here, we also write report, so that when you are faced with practical illustration, report is not a big deal. It's about your understanding. People should not write report for you. As a matter of fact, for serious students, you should not give your analysis out except you need assistance. Then when you are assisted, you get a level of assistance, not total level that you will not be able to defend your work. Okay, so that's what it is we are supposed to do. So I'm going to switch now from my recording. I'm going to switch to the output. To the SPSS screen, then we'll look at how we can, see our data. Well, Prof has given us examples of what we have. This is a population, okay? Variable view. We just have two variables where we have height and weight, and both of them are on scale, which means continuous variable. And if you look at, we have a lot of data here that we have entered. We have 383 in number. But I want you to notice something as I scroll up. Something is predominantly happening between the height and weight. And I want someone to tell me your observation. Because when we move out of, when we are done with this, we are able to get to t-squared today. Instead, one of the conditions of correlation is that you must not have what? Outliers. It didn't say you must not have what? Missing variable. It said you must not have an outlier. So if you look at my height, there's something happening to the data we have taken for the height of people here and that of the weight here. Okay? And I want you to tell me your observation as I move up. Just tell me your observations. Anybody? What did you observe between height and weight?
Some values are missing.
Where?
The serial number 5. If you look at the weight, because the weight is sequential from beginning, but when we get to serial number 5, the height there is 62.46. If you look at the weight, that is an overweight in the way I can explain it.
All right, thank you. That is number one. That is number one. All right, there is one other obvious one that we are actually talking about. Yes.
Okay. There are a lot of missing values.
Thank you.
Particularly for the weight. And then I also noticed that for the weight, we have a few outliers, people who weigh over 300.
Thank you. Thank you. I've also seen that. We see that in the diagram. We see the outliers. And from what we saw earlier, when we see the outlier, you discover that the dot will shoot outside the range. Those are observations that we should have. So all our observations are actually correct. So, and when you have outliers sometimes in your report, you should be able to mention it, because if you don't take care of it, then it's going to appear in your output. Then you should be able to mention it. Like one of our observers mentioned, when you have your height is just 62, and here you are over 200. Wow, that's a lot. And here is almost the same thing. So let's analyze. Let's start from the scatter diagram. Okay. So how do you do that? Just go to what? Go to graph. Go to legacy. Okay. Legacy dialog. right? And go to scatter or what? Or dot. And click. We don't need to select the data. The SPSS
Sir,
has.
please, after legacy dialogue, where are we going, sir?
Okay. Just be patient, madam. This is recorded. So it's just going to capture everything. Whatever I'm doing is going to, you can always replay it. I will repeat that again. And if you don't understand, please just call me back again. Despite the fact that you have a recorded version at the end of the day, it's also good for us to have it. Just click on what? Graph. And you don't click anything. Just stay on legacy dialog where you have a button by your right have that has options, almost 12, right? 11 chart. Just click on graph, stay on legacy dialog, and sub dialog box will appear. 11 in number. We have bar chart, 3D bar, line, area, pie, high, box, etc. But our destination here is what? Is scatter and what? And dot. Then you click.
Scatter and dots.
You click, thank you. And when we have scatter dot as a title here, we have different versions of the scatter dot. We have the simple scatter, we have the overlay scatter, we have the matrix scatter, we have the 3D scatter, we have the simple dot. But I want us to, the note that is directing us, which you will have later, you have it on your table. We are picking what? Simple scatter. And you click what? Define. Now, when you click on define, because I have worked on this before, you should have this way, picking the variables we have. So you can define your variable. Earlier on I said what determines your x and y axis is u. But what is constant is where x-axis will be and where y-axis will be. Remember, our x-axis is the what? Is the horizontal what? Horizontal value. So if you want to put x-axis there, as we have earlier, outside, what was on our x-axis, class? Do you remember? Is it weight or height?
Height.
Okay. All right. So okay. So which means that our y-axis is what? Is weight. So I click on weight, and I move it to what? Y-axis. And I click on height, and I move it to what? Y-axis. And that's what we have. That's what we have. You don't need any other thing. You don't have any other thing. Just click on or do any other thing other than what we have done. Just click on OK. And our result is here. Our result is here. But you will discover something, that we don't have the line that shows the linearity or non-linearity of our what? Of our scatter plot diagram. And there's something you will notice here. Those outliers, you can see this is one of the outliers. How? Prof has told us earlier, if you want to measure this, draw a line from your weight. This one is about how many weight now? Almost 350. And the height is just what? Look at. Wow. The height is not even up to 70. That's an outlier, isn't it, class? Look at it. Look at the direction of my arrow.
Yes, sir.
That's it. That's a very big one. And if you go here too, this is another one. Even though they has the way the height is almost corresponding, but not as much as it should. So this is a very good example of an outlier. Now, how can we get our arrow that cut across this, that shows the direction of our linearity? Just double click this. When you double click, we have this. We have come to this side too. We have come to this side where it's giving us a better version of what we have. Then you go to element. Go to element, click on what? Fit line at total. And another tool will show. Then from there, just click on what? Linear, and click. The moment you click on linear, we have the linear output out here, and you close. That is it. And you close.
Sorry, sir. Can you just go over that again, just a little?
Yes, of course. I can. All right. Let me just Okay, let's run it again. Let's run this again. Let's run this again. Oh, sorry. All this while I'm supposed to have shifted to my output. I didn't. Oh, the recording is not going to capture that. Okay, we can just do it again now. Let's go back to SPSS. I have to switch to output before the recording can capture all that. So we have the data here. We go on graph, we go on legacy, and we go on what? Scatter plot. And we pick simple and we click define. And we have defined this, we click OK. And I switch to my output place. SPSS output, and we are here now. Now it's going to be captured in the recording. Now we have this. We want to show the linearity of this scatter plot or non-linearity. It's not something you determine. It's something the system has already, and it has. It can, from the reading of the line, you can determine the strength of your relationship. The strength of your relationship. So how do you do this? Double click this, and you have this, coming. We call it chart editor. When you have this chart editor, click on element, one of the toolbar, the fifth toolbar here. Click on element and click on fit line at total. Okay, and we have everything coming out because this was initially selected. That is why you have it sample here, and we have it outside here. So if this is your choice, just click on close. And if that is not your choice, assuming this is what you want to measure, you click on that and click on apply, and you have it there. And it shows we in mathematics this is a linear equation, and the equation is shown. But if that is not your choice, you go to what we call lawyers too. You also apply, and it shows you all that. It shows you where you have problem. When you have what we call a clumsy data coming together, and you can explain that in a research. You want to show quadratic, you also apply where we have a quadratic line, and the equation is also there. And lastly, when you also have cubic, and you have it there and it shows. But for this lesson, we're actually interested in showing what? A linear and non-linear application. So I click on linear again, and I click on apply, and we close. And we finally close our chart editor, and we come and see the output here. Okay, and from the output, you can see your equation coming out. All right, so any question before we go to finally on the analysis of the correlation here? Yeah.
Yes, teacher, good morning.
Yeah, morning.
Yes, mine is like observation in the data given as height and weight. I don't know, it is always maybe good to know which measure have been applied, if weight is kilograms, kg, or height is like meters, because I'm somehow confused. For example, if I suppose that someone kg weight, to me, weight, what you are calling weight here, if I say kg and centimeters, I may reverse the information. You may think about that.
All right. Deogratis, I quite agree with you. Thank you for that observation. Let's take note that our unit of measurement here is kilogram. Are we together?
Kilogram
Yes,
now.
sir.
Thank you. All right.
Is it possible that someone may have like 200 kilograms and yet have a height of 70 centimeter? That one is special. I said may be a reversal.
This
What
is
you are calling it?
hypothetical.
Yeah.
It's an example for us to understand correlation. So don't take the values to heart.
Yeah.
We just want you to understand how it is done. Height is in centimeters, yes. Weight is kg, but don't take those data as, oh, okay, somebody is tall, somebody is an hypothetical example.
Thank you.
Hello?
Thank you, Prof. Thank you.
Thank you, ma.
Yeah, Mr. Deogratis, do you understand that?
I understand.
Yeah, no, the data I'm using for you, all this while we cannot work on statistics without having data. There was an assignment I gave you last week on evaluation of the university campus. I said, go. You don't submit, go and get your data. It will take a long time to get data and work on it at the same time. But here we have to work on, we can't wait. We have to get something to work. So the data I'm working on is also actually a data that I extracted from the public domain, from the internet. So sometimes it's just something to work with. They may not give us real life scenario of what it should be. So by the time we get into practical section ourselves, we will see the reality when we think about the unit of our measurement, the weight, and the height. I hope you understand, sir. Mr.
Yes,
Degatis.
my fear was that no one is lesser than 100 kg in terms of weight. This is where I
Yes,
was having the one.
I agree. I agree with you. I agree
That's
with you.
why we are saying it's example.
I
It's
agree
not
with you.
it's example. It's hypothetical. So
Yeah.
don't bother yourself with that.
Yeah.
Just bother yourself with understanding how to carry out this analysis.
Yeah, I agree with
Thank
you.
you, ma'am.
Yeah, you can as well take the weight as centimeter, and also the height in the same way, centimeter. Okay, but in actual reality, our weight is not measured; it should be measured in kilogram. Thank you so much. Now, with this understanding, let's go back to our data. And
Hello, sir.
all right,
Hello, sir.
yeah, excuse you. You have the
Hello,
floor.
sir.
You have the floor, please.
Hope along the line, sir.
Go ahead.
Sir, about the graph, sir.
Yes.
When I actually plotted it using height to be on the y-axis and weight to be on the x-axis, is different from.
Yeah, we can actually try that again. Thank God you've done it on your own. We lost your voice probably due to internet anyway. Due to internet, we lost that. But if you want us to do that together, okay, go ahead.
The example you gave us in class,
Yes.
the height is on the x-axis, while the weight is on the y-axis. And we
Okay.
got the equation says y is equal to 99.56 plus 4.13. But mistakenly, while I was doing it, I plotted it the other way around.
Yes.
And I got y is equal to 56.05 plus 0.
Yeah, I get your point. Thank you. So let's just, when we had it in class, we also have a height and weight, the same thing. And you can try the other way around. You can try the. Yes, yes. You can try the other way, which you have done. I want you to try your hands on that and share your experience with the class. Thank you, Mr. Madam Lolade. That's not. Very soon we'll have to collect our own data and see how we can analyze it. Do I have your permission to go to the correlation now and finish our analysis?
Yes, sir.
Okay, so
Yes, sir.
thank you. So I'm switching back to the input of the SPSS. Let's finish this before we go to another. All right, so we are back here. What we just did now, from the analysis of what we did, it shows that we have a linear correlation, though not totally perfect, but something. It tells us that a possibility of what is significant relationship. When you have something linear, there's a possibility of significant relationship, which means as the weight is going, as the height is going, the weight is also building up at the same time. Now, how do we do this analysis? As mentioned, we go to analysis and we go to analyze on the menu bar. You don't have to select anything. We don't select anything here. Just go to analyze, and when you go there, you go to correlate, and you pick what? Bivariate. And we have this tool here. Oh, because I've done this before, so that's why I have it selected. Otherwise, we should have it this way. Okay, this is as the default value should be. So let's pick that again, and I go back. We go to correlate, bivariate. I return this. As the initial value. So what do? We move our variable from the bivariate correlation you can move by double clicking. We have established this a long time ago. Now the system is not going to tell us which one is X, which one is Y. There's no provision for that here. All we need to do further is by clicking on what? The correlation coefficient we want to use. The question said we should use this, and that is why I'm clicking on this. And nothing more. By default, we are on a two-tail scale, and that's why two-tail is selected. If you needed to move forward to options, you can click, and we established this earlier. We don't have anything here to support us. We don't need anything here because we are not working on more than 2 variables. So this will never affect our result. So I click on cancel, and it says flag bots significant what? Correlation. And I click what? Okay, to finish. All right. In case you don't know what reset means you are going back. Okay, that's what we mean by reset. Go back is reset. We've done all our selections now, and I click on OK, and we have our result. Sorry, I need to go and switch to what? Result mode before that will be captured on the video. Okay, we are on the result mode now. Remember, this was our diagram, our linear diagram, and here we have a what? Analysis here. Outside here, we have our correlation. We have height, weight, and we have Pearson correlations, significance level is two-tail, and after that we have n. This is our numerical value. This means total value, and we also have total value here of our n, and we have weight here, and we have height here, we have weight here, we have height here, we have weight here, and there are 2 other things here that we should take note of. Where we have double asterisk, it shows us that there is a point there we need to take note. So we need to report that we have correlation is what? Is significant at what? 0.01 level of two-tail. We have to take note of that. So what is the meaning of this? We are going to go to the other side now to find meaning to this. But before we go, I'd like to call your attention to something briefly. If you look at this, look at our width. I want to show you. I wish I can draw a line, which I can't. I wish I can draw a line. Look at the side of width here. Look at this side. Look at this side. Good. And look at this side. This is 520, 000. Take note of that. It has a meaning. And also 520, 000, and 323. Here we have, that is for weight. That is for weight. Here, this is for height. This is for what? This is for another height here. Now, take note here. We have 383. We have 323. We have 1. Now, may I ask the class that know that this is the total variable considered on height, 383. This is the total variable considered for width, 332. Meaning that is the total. I did the descriptive analysis here, where we have 332 as what? As the valid variable. We call it valid variable. The others were what? The total. Remember, we had a total of what? 383. Yeah, they were what? They were missing values. So
Yes, sir.
yeah, this one has no missing value. This one has missing value. That's why the numerical, the total number of outcome is not the same. Please take note of that. If you want it to be the same, fine. But the assumption is saying that it does not affect your result. The only thing that you must stand against is what? Is outliers. Make sure you don't have outliers. And at this level, I expect us to be able to understand what we mean by outliers by now. Do I have any question here before we go to the interpretation of this table? Any question? We'll go and we'll go and interpret this now and understand it. Yes.
Hello, sir.
Yes. Go ahead.
Yeah,
Mr.
please,
Afolabi.
with this figure now, the data you gave to us, if, for example, we want to analyze the data,
Yes.
and do we first of all go to descriptive statistics to find the mean, mode, whatever, before coming to a correlation?
You see, it is based on your understanding. If you like, I wanted to prove to you why the total value of our outcome. So sometimes you may want to validate your output by going to descriptive statistics. You don't have to, you're not going to show the report, but that is in your brain for you to be able to understand the report you are presenting very well. And especially if you know SPSS very well, you need to be sure that what you are presenting as your output is correct. You need to know when error is coming in and be able to justify the movement of that error. Where is it coming from? If it's the one you have to go and block, you need to block it. If you do the frequency distribution, it's going to show you in table how many is valid, how many are not valid, what is the cause. It's going to tell you missing value 10, not missing value. We did that earlier when we started analysis. So the best way is to on your own show a description of what you have. Know the valid data, know the non-valid. Then you can correct it. And that's what we did, part of what we did last week, by removing what? Removing the missing value. When you remove the missing value, you run it again. You discover that you have a perfect data that should generate your perfect result. So sometimes it's necessary, even though none required. I hope you understand, Mr. Afolabi.
Yeah, yes, sir. Thank you, sir. Right. Because why I'm asking the question is, if we have to do it manually,
yes,
for us to get to a correlation, we have to find the mean, mode, median,
exactly.
Yeah. So that is why I want to find that.
Yes, you don't need to.
Thank you, sir.
You're welcome. All right, let's switch over to our report where we can have correlation.
Sorry, sir.
Yes. Go ahead.
On theoretical explanation that you gave, I don't know if I catch it well.
Okay.
You mentioned somewhere that before we test for correlation, we must not have missing value and outliers.
Okay.
Have I get it well or not?
Okay. I didn't take note of this. For correlation, one of the assumptions is that you must not have an outlier. And we established how we can get outliers here. Assuming that this hypothetical data we are using is correct, how can you have somebody with 350, weighing 350, who is not even up to what? Who is not as tall as what? 70 kilogram or 70 centimeter of height. Is that possible? Look at the height, yes, in centimeter or in what? In meter. 70 is not up to 70. So it's not, there's something wrong. And that's why we can refer to this very variable here as what? An outlier. So we must eliminate outlier as much as possible when we are going into correlation. Otherwise, it's going to create error in our data. It's going to create error. So that's what we are saying. It's not both outlier and what? Missing value. Correlation will accept missing value, but will not what? Accept outlier. And look at this. We have missing values here. Here, we have missing value, and your result is calculated based on the missing value. Here, there's no missing value, and it's calculated based on non-missing value. That shows that we don't have error there. So I hope this is clearer to you, Mr. Deogratis.
Okay, sir.
All right, so let's conclude this report and see what else we can do before we finish today's class. Okay, we've seen this. We've generated this ourselves where we have the width over the height. And we move down to, this is the theory. This is all that the procedure you take is here. And we have the result as what we have on the screen. You discover that there's a total variable between what they have and what we are having. Look at the total value of the height. It's different from our own height. Our own is 333 or so. Why? Because I used the data we used last week. I have eliminated some what? Some outliers. So that has reduced our total number of outcome. Remember, okay? So the next thing, so don't bother yourself about this data because we have worked on the current one we are having. That's why our data is not capturing exactly what they are capturing. But however, our result is still relatively close, and that is not affecting our result. So now, how do we report this in case you have it? Take note of A, B, C, D and know what we have there. Please, we are going to go straight away. We will interpret this in that regard. A, B, C, D. Now, the first one here, let me reduce the screen so that we can capture it one way or the other. The first one has to do with what? Correlation of height with itself, where we have R as what? As 1. The relationship here is what? Is 1. And the number of non-missing observation is what? It is non-missing. It's a non-missing observation. Is what? 408. Remember, our R is 1. Our non-missing value, which is N, is what? 408. Let's leave that to the next one. Let's go to B. If you look at this, what is correlation of height and weight is what? Is R, which is what? 0. What? When we have point, this means 0.5. Our R here is 0.513 based on what? Value of what? 354. I repeat, correlation of height, just like we have here, correlation of this is 1 over the total number of outcome. And here we have a correlation of 0.513 with what? The outcome of what? The outcome of 354 in the height there. And observation with what? Pairwise non-missing value. This one is also what? Pairwise what? Non-missing value. That is for this B. Let's go to C. Here, by looking at this C, we have our, for the weight, we have the correlation as what? Our R is what? 0.513. And we have the total number of outcome as what? 354 non-missing value. That is what we have in C. And let's see, correlation of height is R is this, based on N is 354 observation with pairwise non-missing value. And the last one is 374 non-missing value. However, there is something we have not reported. 0.0000. 0.000. And we have something here telling us the meaning of that. And that is the next one. Now let's look at this. The important cells we want to look at are what we have seen. Okay. For the correlation between height and weight, its p-value and the number of complete pairwise observation that the calculation was based on, we have reported that very well. Okay. Now, this is how your report will come. This is your report, class. This is your report. And look at this. However, notice, however, that the sample size are different in this and this. Do you notice that? We have defended the reason. This is because of missing data. There are no more missing observation for variable weight than are for variable height. On our own side, we have eliminated all from weight. We only have from what? From height. Take note of that. Now, how would you now present your result eventually? If you have opted to flag significant value, which we did, and that's why we have this significant value showing here, and finally we have the correlation here 0.01, which means that the moment your significant value here is less than 0.01, it means your result is significant. Correlation is significant at 0.01. Sometimes it goes for what? 0.05. But for the scientific area, where we deal with life, we eliminate error as much as possible. For social sciences, it's not actually live. You can still allow the error gap to be up to 0.05. Now, you now conclude here that if you have opted this to appear, SPSS will mark 0.05 significant level with 1 asterisk and 0.011 significant level with 2 asterisks with this value. Why? I have explained the difference between this and this error. This error gap is only allowed in health sciences because we deal with the life of human being. Okay, we can't allow such to be as large as this. Otherwise, how many people do we expect to come out of the hospital when they visit the place? So in cell B, repeated in cell C, we can see that the Pearson correlation coefficient in height and weight is 0. In cell B is 0.15, okay, which is significant at what? P less than 0. Which means your P, all your P at this level, this is what you are recording, is less than 0.01 for 2-tailed test based on 354 complete what? Observation. So this is how your report will come out, class. This is how your report will come out. This is how your report is going to come out. And then, how do you summarize this if you're actually reporting out? This is what you write out finally. You don't have to write it this way. You leave all this non-missing value out. You don't need to mention that. So we can write it in another form, coming out this way. Weight and height have a statistically significant linear relationship of R 0.153 and P is less than what? 0.01. You discover that they left the first 0 out. Yes, it can be. You can do that, and you can also include it. It is not an error. Therefore, the direction of relationship is positive. How do we know that it is positive? We saw that in this. If you don't know the direction, you can go and run this. It will show you. And you have the equation that shows you. If the equation is negative, it's going to show negative. How did we see the equation earlier? If I flip back to my output, you see the equation in the output. And this is what we have here on the output section. Okay, look at the equation here, class. Can we see the equation? I'm trying to make it big. Can we see the equation here? And it's positive.
Yes, sir.
Yeah.
Yes, sir.
Yeah, it's positive there. Okay, so let's come back to our data and conclude that. And if you look at also, yeah, all right, ma. Let me just conclude this on the report here. So let's look at this now. Let's conclude on the direction. The relationship is positive. Height and weight are positively what? Correlated, meaning that these variables tend to increase together. Width and height tends to increase together. If one actually outweighs the other, then we say there's a problem. Just like someone, detected. Deogratics say, oh, how can we have so weight? Assuming that the parameter is kilogram and centimeter or kilogram and meter. He said greater height is what? Associated with what? Greater weight. So we now conclude that the magnitude of strength of the association is approximately what? 0.3 to what? To 0.5. Meaning that if you relate that to what we have up, it means that we have a what? A strong relationship. Let's flip back to what we have earlier established. Yeah, here it means we have what? We have moderate. We have a moderate relation. Not strong as we explained, and we have seen reason why we can have a strong relationship. For us to have a strong relationship, we need to have a very good example and get a good data that can actually give us that. All right, Prof, you have the floor, man.
Okay. Please, can you go to the results again? I mean the results of the analysis.
Okay. Is it okay?
Yes,
Right.
please. This is what Dr. Manito and me has explained. For those of us that are very familiar with statistics and the mathematical.
Sorry, a minute, man. Let me flip to the results from the video. Otherwise, all that you are saying will not be captured, man. Just a minute. Okay.
All right.
Yeah. Okay, go ahead. Yes.
Yeah. So just looking at it, you already understand what this means, because if you look at height, under height, you have 1, and then that's the A space, you have 1, and then 408. And as he explained, this is correlating height to height, correlating the data you have under height with height. That's why it's a perfect 1, positive, because it's the same data. But now correlating height with weight shows that there is a significant positive relationship. That's why you have 0. There is no 0 there, but you can see the point, 0.513. And if you go back to the page we just left now, that shows how you describe the strength, shows that, or the magnitude, it shows that if it is between 0.3 and 0.5, it is moderate. If it is 0.3 and below, then it is low. Right, okay. 0.1 to 0.3 is a small or weak correlation. But if it's between 0.3 and 0.5, it is medium or moderate correlation. And ours is 0.513. So which shows, yes, there's a positive linear relationship, but the relationship, the magnitude is what? Is moderate. But when it is higher than 0.5, above 0.5, then you can say it's a strong relationship. If what we have now is 0.7 or 0.7, 0.8, then it is very strong. So or 0.9 is a strong relationship, strong linear relationship. So it's correlating height with weight gives you 0.513, and that's why even the second line, so where you have weight and height, is still 0.513, because it's still the same correlation of height and weight. The second column, if you have, that's the second line, where you have a perfect 1, yes, is also correlating weight with weight. So weight with weight is 1, because it's the same data you are correlating. Height with height will be 1, because you are correlating the same data. But now when you correlate weight and height, it gives you the 0.513, which is significant, but it is the relationship, the magnitude is moderate, because it is 0.513. Between 0.3 and 0.5 is moderate. Below 0.3 is small. And then above 5.5 and above, that is tending towards a strong relationship. So that's just what I wanted to stress. And that shows that as height is going up, the weight is also going up. That's the relationship between them. If it is negative, it might mean that as the height is going up, the weight is coming down. Yeah. And so the R there will now be negative. We didn't put positive there because once there is no sign there, it shows that it is positive. But if it is negative, that is, one is going up, the other is coming down, there will be a negative. It can be negative 0.513, which is still a moderate relationship, but it is significant, and one is going up, the other one is coming down.
Thank you, Prof. Thank you so much. Thank you so much. That was highly needed. Hello, gentlemen and ladies. I don't know if we have questions based on, we have come to the end of correlation, both analysis, in the analysis and the reporting, by using diagram to defend our concept and using the analysis to also show our discussion. We have come to the end of this. But before we leave here to another, because we are moving to another topic right away, let's know if you have questions, and let us know also if you, yes.
Okay, sorry. Just a paragraph before the conclusions where we draw the inferences. Yeah. The report, is it auto-generated by SPSS?
No, all these are not. No. This is what you will have. This is exactly okay. This is what you will have. Let's go back to the SPSS output. That's a good one. I like that. I like that. This is what will be generated to you, sir. This is what you will see. This is it. This is it.
That's what I have. That's the only one I have.
Yes. In case you have this, you have to interpret this diagram. And that is, how did we interpret it? We have so many theory that we explained earlier, and that's why Prof, took us back, and I'm happy she did. I also tried to flick back, to the note. How did we arrive at this conclusion? The weight and height are statistically significant. How did we know that? Because this is height and height here, where we have one perfectly one. Here we are talking about height and weight. We have a correlation. Here we are talking about weight and height. We have a correlation here. So we can say and look at the correlation value here, giving us 0.0, and the answer, the result is there. It's saying now whatever we have here, the moment whatever we have here is less than this, it means it is what? Significant. Then from there too, we have our R value reported here as well, 0.153. So we report our R value. We also report our what? Our P value here. Meanwhile, we don't need to report the number of outcome, which is 354 and 354. We don't need that. And that is how we, concluded on this. So this is from the table. All right? And how did we get this? This one and this one. I said the direction of the relationship is positive. It's also from from this result. If it's not positive, it will be showing us what? Minus in any of the results here, right? It will be showing us minus here. And further to that, the last point is this. How did we get this? If you look at the table here, where is our result? Moderate between what? 3 and 5. Did we get 3 and 5 here? We have our 5 value here, and you go up to the interpretation is here. The interpretation is further illustrated here, where we had this establishment. So this will go with you all the time, with whatever questions you are bombarded with. Let's try and put this in our left-hand side so that we don't eat with it. We can always use this to interpret our values. So our further interpretation came from this. So like the question came, does SPSS auto-generate the result? No. And that is why we need to understand SPSS so that we can make our inference from the theory and from the result. This is from the theory, and we merged it with the output of our SPSS. I don't know if you understand this better now.
Yes, I do. Thank you so much. I appreciate it. Thank you.
All right. Do we have other questions? Otherwise, we use the remaining 15 minutes to open up another topic of discussion. Remember, we don't have time. So we can't afford to say we are leaving, we are closing on this for today. Sorry, we have to get to that level. Remember, we just have about 2 more lecture period after today. Do I have your permission to go to another topic, class?
Yes.
All right. Thank you so much. So, yes.
So I think somebody is asking a question at the comment section.
Oh, at the comment section? Please, you can read out for us in case we have that. I cannot see that here. If you have that, please read out for us. Read out for us. Read it out. Read it out for us if you can see that.
I can't see it. I saw it when she sent it.
Can you read it? Okay, let us. Okay, let her speak to us if we can hear her too. You can speak to us too. Okay, we'll take your questions when we hear them, when you are ready. You can type on the WhatsApp later, or you can still drop it here before we conclude this. Now let's take the remaining few minutes. I'm going to give you assignment on t-test. So let's understand this as we move along. It is obvious that we cannot conclude this. So wherever I finish or wherever we stop, I will ask you to finish it. I'm going to give you the output. You have the data already. So you run the SPSS, compare your output to the result I'm giving you here. Then we can move from there next week. Thank you so much.
It is sent by Fatima.
Okay. Thank you. Can you read it?
So what is the implication of significance of one tail and two tails?
Oh, good. Now, if we established an assumption, remember, thank you, we said earlier that why do we have hypotheses? hypothesis is a statement of assumption. You need to set an hypothesis. You need to set a target so that you know what is guiding your research. And your hypothesis is just an assumption that you are not sure your assumption is going to be right or wrong. Sometimes you make valid and right assumptions. Sometimes our assumptions are wrong, but that is why it is a research. We don't have the result. So now we look for a two-tail when you are running a null hypothesis with an alternative hypothesis. You also run a one-tail test when you are running a null hypothesis with hypotheses that are greater than or less than a null hypothesis. Now we are not saying it is not null. We are saying that a one-tail is greater than a null hypothesis. So the statements are not the same. The first one, which is two-tail, says no and yes. And the other one, which is a one-tail, says no and greater than what? No. So when we say greater than no, it means it is not no in actual sense, but it is not going to give us absolute one. So it is a statement of hypotheses that differ in expression, and at the end of the day, you compare your results to the hypothesis you have made. If your result is the same thing, falls into the assumption you made, you will accept the assumption. If your hypothesis falls short of the assumption, then you will reject your assumption. We are still going to see further solutions where we have to reject. Hypothetically, the last example we gave now, we did not actually set an we didn't adopt any hypothesis, but we could have adopted that it is not, our width will not be equals to height. If we have done that, then we would have rejected our hypothesis, because at the end of the day, our weight actually equals to height. There was a significant relationship between what? Our weight and height. So I don't know if she's here, if she's satisfied with the explanation. We'd like to hear your voice. Otherwise, we can still give you more content to go and read.
So she's in a place where she can't talk.
Okay. All right.
So, but she already said thank you, sir. So that means she understood.
Thank you. Prof, do you have anything to add to that?
Yes, just to say that invariably, the way you interpret your result is based on the hypothesis that you set at the beginning. Okay. So whether it's a two-tailed or one-tailed hypothesis. So that's the way you also interpret your result.
Thank you, Prof. All right, let's move on to further. Remember that we have finished descriptive statistics. The moment we finish compare means, we move to what? Chi-square was one of the examples that actually launched us to what? Inferential statistics. So we have finished chi-square. We have finished we have finished what did we finished correlation, and we are moving to a t-test now. So we have a t-test and we have independent t-test. I will just give you examples and questions that will expose us to independent t-tests where we can test multiple groups. We cannot do more than just a class on t-test. I will just give you examples that will expose you to others, so that by next class we go into ANOVA. And when we talk about analysis of variance, which is by short acronym ANOVA, is large. We have ANOVA, we have MANOVA, we have covariance, we have varieties of them, depending on the values or the groups you are exposed to. So we will just teach you the basics, then you can expand your knowledge. I can give you books to read and that have practical data set that you can run, that will guide you. But the concept is that don't be confused when you are doing it, and you can still come back, when you need help, so that we can put it through. So one sample t-test. This examines, remember the last one we just finished, correlation, was, who can tell us the major conditions that can allow us to use correlation? There is a major one that we must consider. Who can remember? And the moment you can remember,
Continuous variables.
thank
You
you,
must have continuous variables.
thank you, very, very important. The two must be continuous variable. Now for t-test, it is another condition. So someone asks, how do I know the statistics I will apply or the SPSS I will use, statistical analysis I will use when I have question? That's why we keep mentioning this. Another condition that is appropriate with correlation is that it is what? Relationship. Relational. It's relationship. That is it. So we are moving out of that now to another condition or other conditions there that we should always remember too. How do you remember this? You read. That's the only way. And by the time you read, you get used to it. Now, one sample t-test examines whether the mean of a population is statistically different from a known or hypothesized value. What do we mean here? I want to compare the fact that I'm a man and I have another man, and I want to say I'm older than you. If I say I'm older than you, then we have to test some variables. Let's collect our age. Let's collect other parameter that we can use. Maybe you want to use height as a value to indicate that you are older than another person. So you now find the mean and compare the mean. So when you find the mean and compare the mean, that is what we use. That's what we use t-test for. And that's why we say t-test examines whether the mean of a population is statistically what? Different from another what? Hypothesized value. So one sample t-test is a parametric test, just like I've just explained. The test is also known as what? A sample t-test. Variable used in this test is what? Is a test variable. Now let's look further on some conditions that we should have. We use the t-test variable mean as what? A compare variable called what? A test value, which is known as what? Hypothesized value of mean in a population. Let's look at these two examples here before we see how we can break it down. A particular factory. May I ask if you can see the screen?
Yes, sir. Yes, sir.
All right. A particular factory's machines are supposed to fill bottles with 150 milliliters. 150 milliliters of products. A plant manager wants to test a random sample of bottles to ensure that the machines are not under or overfilling the bottles. Which means you want to test that the machine can fill the bottle adequately so that you don't have it underutilized or what? Overutilized. You use a t-test to compare the mean of the two. Another example is this. A United States Environmental Protection Agency called EPA set clearance level for the amount of lead present in homes. No more than 10 micrograms per square foot on floor, and no more than what? 100 micrograms per square foot on window sills, as we have in December 2000. An inspector wants to test if samples taken from units in an apartment building exceed the clearance level. We have been given the clearance level, so you must now go and be taking samples from homes. Compare this sample with the mean that has been established. The moment you have this more than what has been established, it means that particular building is in trouble and they are exposed to what? To lead, excessive lead. That's an example here. We'll see simpler example as we move on. Now, when do we use this? How do we use it? One t-test is commonly used in testing this. 1. Statistical difference between a mean and a known what? Hypothesized value. Now we have an hypothesized value here. We now collect the mean of each houses, compare it to the value we know. So you must have a value as a test parameter. What do we mean? You have a marking guide. You now collect some data. If your data is more than that marking guide, then you have set the result. And if it's less, then you have set the result. What I mean by marking guide is a baseline. Is a baseline that you have, that values should not be more than that. Let's go to ourselves, our life scenario. We talk about high blood pressure. Those who are in health industry have established certain parameter for normal high blood pressure. We have the systolic, we have the diastolic. We have the normal level to be 80 by 100 by 120. Now you now want to know the lifespan. How are people dying in a community? That the death of people are increasing. You now took their blood pressure. You found the mean of their blood pressure. You now compare it to the what? To the baseline within normal health. And you have different categories. We can use t-test for this. Remember, these are values. These are values. These are values. These are not string. These are numerical values, which we mentioned earlier. They are numerical values, and we'll still go into that. So that's another example that we can have around us here. So we can use statistical difference between a change score and 0. This approach involves creating a change score from two variables and then comparing the mean change score to 0, which will indicate whether any change occurred between the two time points for the what? Original measures. This is another one. Okay, let's note that the 1T test can only compare a single mean to a specified constant. I think I mentioned this. Single mean. For example, single mean 1 to 1, one person to 1, meaning that Mr. A blood pressure to the parameter of the normal pressure. This is a one single mean we mean, not a group. Group means that you want to compare the mean of a class. That's a group. That's a group. Excuse me. Sorry. Sorry, I will call you back. I'm in a class. Okay. Yeah, I will call you back. I'm in a class. I'll call you back.
Okay.
I'll get back to you. I'm in an online class. I'll get back to you. Okay. All right. Sorry about that. So we have that. That is 1-to-1. When we want to compare a group, for instance, you want to compare your class A that you teach, population of about 20. You want to compare the blood pressure of male and female. You want to compare it to the parameter. Then that is group. And that cannot be done by t-test. We can move from there to what? Independent t-test that we can use group. Right? Or you move from there to what? ANOVA, analysis of variance. And when do we use mostly analysis of variance? We use it for experimental cases. For example, we can compare dependent and independent variable. We can compare experimental and what? Control. When we have two-way or two different mean of two groups. So for one dependent or one single mean to a constant, we use a t-test. So it cannot compare simple mean between two or more groups. That's why I put this in a different color. It cannot. If you want to do that, you go to independent, or more so, you go into what? An analysis of what? Of variance, where we have versions and conditions of so many of them, which we will see as the class advances further. So if you wish to compare the means of multiple groups to each other, you will likely want to run an independent sample t-test, as I mentioned, or to compare the means of two groups, or one-way ANOVA, which is one way or another. The full meaning is what? Analysis of variance. AN, analysis. O, of variance, to compare the means of two or more groups. Independent t-test, we compare two. When you want to have more than two, use this. It will take two or what? Or more. May I request, if you have questions, contributions will also be taken. I will soon stop from here. I will ask the class to read further. I have the questions here. You can skip the statistical level. Skip all this. You don't need this. You may not need this except you are the ones that are within the numerical area, but it's not determine the knowledge of your SPSS. Just go straight to your what. You can start from run a sample t test down. You can start from here down, which have examples and a very interesting variable. Interestingly enough, the variable we used earlier is the same variable we are using now, which was what? Which was based on what? Height and width. Which was based on height and width. So it's still you still have the same data. It's here, same height, and yeah, the same height, and I think basically it was just height. That's what the question is on. So let me take your comment and questions and contribution too, if you have any. By my time is few minutes after 9. I will want to take or engage you further than this. It was not a signed agreement. Some of us are engaged in other areas. So let me not take that for granted, even though we have so many things to cover. But I will leave the rest for you to read, and I will give the rest for you as an assignment later. I will test the questions I want us to consider at the end of the class. All right, the floor is open for questions, contributions, and also
Hello, sir. I'm
comments.
raising my hand.
All right, please let's organize ourselves. I can't see the back end. Let me start from.
Yes, sir.
All right, go ahead.
I just want to know if you are now telling us that there are different types of t-tests, sir.
Yes.
Yeah.
What we are considering, what we are starting with is one sample t-test. By next, well, I'm not going to teach you, but I will expose you. I will give you questions that will expose you to the other t-tests, such as independent t-tests. Okay?
All right, sir.
Yeah, we have independent t-test, and yes, and we have peer t-test. So we have 3 of them that I'm going to expose us to. I'm not going to teach us, but I will give us questions that will expose us to learning them and to be able to answer questions on the types of t-tests. We have one sample t-test, we have independent t-test, and we have pairwise t-test. Or peer sample t-test. Yes, thank you. Yeah.
My question is on the data set. Are we using the same data set to run
Yes.
This t-test?
Yes.
Okay.
Yes, the same thing. Yes.
Thank you.
You're welcome. I don't know, Prof, I don't know if you have contribution.
Thank you very much. It's been very well understood. Just to add that the correlation, just like you have types of t-tests, you also have
Yes.
the types of correlation.
Yes.
I think under the when we're running the analysis, you showed us that you can use Spearman rule.
Yeah, Spearman rule.
Spearman rule
Yes.
can be used for non-parametric tests.
Yes.
So that just like you use the other one, Pearson.
Yes.
For parametric, you can use Spearman rule for non-parametric tests.
Thank you so much, Ma, for taking us there. All right, may I ask those of us who are here, do we have questions? I know a number of us are not in the science area. Tofumi, are you okay with our deliberations? I hope we have not taken you totally into arithmetic area. Are you still comfortable?
Yes, I'm still okay.
All right, thank God. Other people, are we all right? I hope we are not delved too much. Don't bother. Sorry about it. Myself and Prof, we belong to the science area. So sometimes we might take you to a level that you are not too comfortable. But Prof is trying to bring me down to your level. Sorry about that. Any other person?
Are we reading the document on this t-test? The one I have on the correlation.
So sorry. Okay, I'm not sure. Did I share the content on t-test? Maybe I didn't.
No, I didn't.
All right. Sorry, I wish
Sir.
I did, right? Oh, thank you. So, Mr. Francis. The content is outside.
Okay,
I think I shared it
I'll
early
share it
this
again.
morning.
Thank you.
It's there. It's there. Thank you so much, class.
WhatsApp.
I will give you what
Okay,
I
thank
expect
you.
us to get, what I expect us to do on the t-test. And like I said, SPSS is not something. Is a whole semester course. Sometimes 2-3 semesters, if you want to know, get to the depth of it. But as much as possible, what we will go through within this 7th week is going to be something that we will not forget in a lifetime. So I will give us a lot of practical illustrations that will take us, that will give us more understanding of this. Thank you for coming today, and I wish you a wonderful day. Just on the same level, don't forget, I like to take track of those who came to class. Just tell me that you were in class today. That's all I need to know on WhatsApp. God bless you, and do have a nice day.
Should we go to the WhatsApp page?
Yes, thank you.
And which page?
Yes, just on the
Thank you,
WhatsApp page.
sir.
Thank you so much.
Thank you very
See,
much. Thank you very much.
see you next week. Bye bye.
Appreciate it. Thank you. Yeah.
Thank you, sir.
Thank you, sir. Thank you, ma'am.